Classical Conversations Cupertino. This is Robin Cooper, and I am presenting to you week 22 hands-on science. You're doing Popsicle Stick Catapult. Briefly, what that might look like. I have a bottle cap, I have popsicle sticks and rubber bands. So before we start our science, we're going to remind ourselves what we're doing. We're going to think like engineers. Engineers use three things to create solutions for problems. What are they? They are science, math, and even art. So our problem that we're solving is to launch an object using a catapult. So let's sing the scientific method.
The scientific method is question and research, hypothesis, experiment, analysis, conclusion.
Our question is, how can I think like an engineer to build the type of catapult that launches an object the farthest distance possible in an accurate direction? So we're going to ask three questions in our research. What are the parts of any catapult? That's question number one. What kind of catapults are there? What is the science of catapults? But before we do that, let's talk about what makes a catapult a catapult. A catapult is a ballistic style device used to launch a projectile a great distance, but you cannot use gunpowder or other propellants. So there's no type of explosion that's going to propel this action. There are various types of ancient and medieval siege engines. Have you ever heard of a slingshot? Do you remember the story of David and Goliath where he got 5 smooth stones and he slung around his sling and he released a stone to knock the giant down? That is a type of catapult. So what problems do catapults solve? They allow someone to launch objects very far distances. The catapult is a type of simple machine. Primitive catapults were the product of really a very straightforward attempt to increase the range, which is the distance, and the penetrating power, which has to do with the force of your object, of missiles by strengthening the bow which propelled them. So you needed more force to get bigger distance and greater power exerted. So what are the parts of a catapult? There are 4 main parts of any catapult. They are the lever, that's also called the arm, the base, the tension source, and the basket. The projectile is not actually a part of the catapult, but obviously you need it. You need the payload. It's called the payload too, because you have to think about what you're going to launch. There are 2 different examples I have for you. The first example is on the top of this page, and I'm going to show you a screenshot of this, hopefully in the computer. What you see here is the arm hinged down here at this pivot point. There's tension forming in this string, and you would pull the arm down here and then sling this payload up that way. So you're creating tension here, you're storing potential energy down there, and when you release it, this compresses, and it actually will force this object up at a certain speed and velocity. The second type of slingshot has, or type of catapult, has a weight here, and it has like a slingshot type of arm here with a pouch at the bottom. So you've got the frame, there's a base, there's a beam, there's a sling, there's the payload sitting in the sling, and there's a counterweight. So when you release this type of catapult, you let this gravity pull this counterweight down, the sling releases, and the payload is launched. This is like a slingshot. Usually you would store potential energy. You would create an increased potential energy by using a torsion bundle. So here is an arm. You'd be twisting that arm. It would be twisting these strings like a rubber band. They go down through the hole and they're turned there and they're turned there. So do you see how that potential energy is increasing? Thinking about making your catapult, I want you to think like a scientist and like an engineer, using science, math, and art to design your catapult in a way that is going to launch your payload in the farthest direction, the greatest distance, that's also predictable. You're going to work as a family. You're going to come back on week 24 with one design. You will have 7 craft sticks, rubber bands, glue, and your payload, so that your payload could be pom-pom, marshmallow, beans. Lastly, you need a small bottle cap. Build your catapult at home. Record the type of payload you use and how far the payload goes. And then you might want to hypothesize, okay, which object is going to go farther and why? And then question, did the outcome result as you expected, or was it different? You can modify some things. So you can create more tension. How do you do that? Do you use more rubber bands? Do you change where your joint is? Like, can I make my angle shorter or longer by moving my sticks here back and forth to the end or to the joint? So I might shift this up or down. I might add rubber bands to this side or this side. I might try to make this taller. I might do a completely different design. So there is one design here, just like we did. That's one design. But then there are some other designs you can think about. Do you see these have stands on them? These are some other designs that are interesting. How can you create different types of tension mechanisms? And then lastly, you can pull the arm down to different depths. So the first time I launch my catapult, maybe I pull it down halfway. And the second time, maybe I pull it down the full way, the full depth. I hope you have fun with it. So we discovered we had to use some packing tape to get the,
Did you see that, Joe?
the lid to stick on the catapult. Our first line of defense is going to be
We made catapults!
beans. We're going to pretend our milk bones are logs. We got marshmallows too. Make a hypothesis. How far away you think you have to be?
Whoa! I can't even shoot at the army man.
Okay.
Oh, look how far I shot my
Evelyn's
bean!
guessing how her bean's going to go. I like that.
Look how far I shoot my bean.
Wow, that was really far, Cade.
Oh, wow.
Okay, so
Did you see how far I shot?
I want you guys
Where's
to
my bean?
wait for the count of 3.
Because I did this.
Cade, you want to try to shoot the army men. So you're shooting the wrong
Where's
direction.
the bean?
That goes pretty far though, buddy. 1, 2, 3.
Oh, mine.
Did anybody's attack?
Did you see that?
All right.
This thing went off.
All right, we're gonna try. Oh, try to slide it back on.
Beans on me.
Ready,
My attack.
set, attack.
Yeah. I didn't even shoot mine. Ready? 3, 2, 1. Attack.
Did it work?
No.
Okay, we're gonna try something different. Tell me if milk bones are gonna be more or less effective.
More.
More effective. Or do you think they're heavier or lighter than kidney beans? Heavier? All right. Okay, it's gonna use a boulder. Okay, a miniature size boulder. Okay, ready. Okay. Oh, Evelyn's right in the middle of the army. Okay, ready, set, attack.
I knocked
Oh,
over
he
a man.
Okay.
I knocked over a man.
All right. Now. Yeah.
Baby, I was born to eat
No.
marshmallows.
Share them. Share them. All right. Ready, set it up, attack.
Oh, my stable.
Did you think it's going to be more
Attack!
or less effective?
Less.
Oh, why?
Because mine just landed back there.
It went right back in like
Yeah,
a
like-
boomerang? Wow.
Look at mine.
Went right back to you.
I knocked over another army man.
Come show me your design and tell me how you think you could make it stronger and more
I added
accurate.
another
Can I have
popsicle
another
stick
mice?
to this. I ate mine.
Okay, and what was the reason you added more length to the
So
arm?
it would go farther.
Okay, you thought maybe it'd go farther.
Yeah.
All right.
I made my design like this so it could jump and catapult things really far.
Okay. So, in your catapult.
Meow.
Oh, it's
Uh,
doing a lot of pressure.
Huh?
It's doing a lot of pressure on this, so I'm holding this thing while I do this so it can go like far.
Okay.
My catapult, you can't move. The same design as everyone else's, except look at the bottom.
You can't even do it.
It's this far apart with a rubber band instead of taped.
And
I knocked down 3 army men with it.
Good job.
You have to